So today we're going to talk about practice problems using Charles's law and Boyle's law. So you're going to need your books, and you're going to need to open to page 180. You're going to need your calculator and a pencil. So get set up, and then when you're ready, go to the next slide. So page 80, number 1 says, a 500.0 milliliter volume of gas is measured at 20 degrees Celsius. If the pressure remains unchanged, what will be the volume at 0 degrees Celsius? So let's go ahead and write down what we know. So I've written down the information that the problem gives me. And the way that we keep everything straight is because we know it's 500 milliliters at 20 degrees Celsius, we're going to call that V1 and T1. And so the part that we're trying to solve for the temperature at 0 degrees and what the volume is going to be, we're going to call that T2 and V2. And so then after you do that, the next thing you want to do is write down your formula. And so that's the formula that goes with Charles's law. And so let's predict first what's going to happen. So if they tell me that temperature is going to go down, so remember that means less kinetic energy, so that means the gas molecules are moving slower. But the pressure needs to stay the same. So that means that these slower moving gas particles still need to hit the walls of the container at the same rate. So what needs to happen to the size of the container? If I'm moving slower but I need to hit the walls at the same rate, then my volume, needs to go down as well. So our number better be less than 500 milliliters. So let's solve this with the numbers just plugging into the formula. So we have our formula already written. The second thing we're going to do is substitute in. So plug in your volume on top. And then you're going to be putting T1 on the bottom, but don't forget that has to be in Kelvin, so make sure you convert. So this is how your formula should look when you plug everything in, and then you are just going to solve for V2. And you get your answer to be 466 milliliters, so that agrees with our prediction that it would be less than 500. All right, let's try another one. So this one says, if a sample of gas occupies 100 centimeters cubed at 200 degrees Kelvin, what volume would it occupy at 150 Kelvin? Let's write down what we know. So I'm going to make an adjustment in the problem. So they tell you it's just 100 centimeters cubed. I'm going to make it 100 decimal points so that we have 3 sig figs. So this is the stuff that you know. Go ahead and write your formula and then substitute into your formula. So this is what you get when you substitute into your formula. Let's do our prediction again. So when we're doing our prediction, the information that they give us is that temperature is decreasing. They don't say anything about pressure. The last problem we did actually said that the pressure was constant. When it doesn't say that it's changing, we're going to assume that it's constant. So if temperature goes down and pressure is constant, what has to happen to volume? So you should have said that volume would go down. Therefore, the volume that we're going to find better be smaller than 100 centimeters cubed. Now this centimeters cubed is a weird unit. I don't know that you've actually seen that one before, but 1 centimeter cubed is the same thing as a milliliter. So when you're solving for this, let me make sure that you know how to plug this into your calculator. You would need to rearrange these fractions. So what you should be plugging into your calculator is 100 times 150.0 divided by 200, and then you need 3 sig figs. V2 is 75.0 centimeters cubed. So let's go to page 180, number 3. I would suggest that you pause this and try to work this one on your own. You have 2 samples to go by already. This one's going to follow the same exact format. And then you can play this and see how I solved the problem. But go ahead and pause. You try to solve 180, number 3 on your own. So here's the information that they give me. Here's the formula that I'm going to use. Some people like to rearrange the formula before they substitute. You can do it that way, or you can substitute like I did here with the numbers in. So this is what you get when you sub in, and when you write it out this way, you'll see that milliliters wipe out, so you're left with Kelvin, which is a unit of temperature, so you know you've set it up correctly. Let's do our prediction. So in this case, the volume's going down, but we need to hit the walls at the same rate. So what has to happen to the speed of the gas molecules? You should have said that the speed would go down for the gas molecules. They need to move slower, and so that means temperature goes down as well. So let's plug these numbers into our calculator and let's see if we agree with that. So I get my final answer, T2, to be 113 Kelvin, which is lower than 321, so that looks correct. All right, let's move on. So the problems on page 181 are going to set up exactly the same way, except these are going to be with Boyle's law, so you have a different formula. So let's start these the same way. So I want you to read the problem, and I want you to write down what information is given, and then leave a question mark for the one that you're trying to solve for. So this is the information that they give you. Since they don't mention temperature, you assume that temperature is constant. So then write down your formula. Remember, you want to switch over and do the formulas the way I have them written. They're the same as what's in the book. I'm just rearranged a little bit differently. I think it's easier to memorize the ones that I'm giving you. So memorize the one that I'm giving to you. Now let's sub into this formula. So this is what it looks like when you sub in. Now you just need to solve for V2. But before we do that, let's make a prediction. So when you look at the information they've given us, they're telling us the pressure is going down. So that means we are hitting the walls less often, at a slower rate. But the temperature is constant, so we're moving at the same rate. If we're the gas molecules, we're just hitting the walls less often. So what needs to happen to the volume? You should have said that the volume would go up. So let's plug into our calculator and make sure. So when we plug this into our calculator, you do 800.0 times 200.0 divided 760.0 for sig figs, and sure enough, volume of 2 is greater than volume 1, so this is correct. Let's move on to another one. You should be getting the hang of this by this point, so go ahead and solve this exactly the same way. Remember, your steps are... So here are the steps that you would be doing. You're going to create your chart, you're going to write a formula, you're going to substitute values, you're going to make predictions, and then you're going to solve. This making predictions part, you can do up here if you want to, once you see your values, but just do it before you solve. That way you'll be able to check to see if that number makes sense. Alright, so let's go ahead and start page 181, number 2. Pause this, solve it, and see how you do. So this is the values that they give you. Remember, they tell you that you're at STP, and you should know what those values are. They were part of your reading questions. Okay, let's go ahead and do a prediction. So based on my numbers, my pressure is going to go up, but my temperature is constant, so we're moving, if we were the gas particles, we're moving at the same rate, but we're hitting the walls more frequently. So what has to happen to volume? Volume is going to need to go down, so we should have an answer that's less than 420 milliliters. So this is how you should have set it up. Millimeters of mercury are going to cancel out. Plug into your calculator 4 sig figs. Your units that are left over that don't cancel are milliliters, so that's the units of your answer. I get my volume to be 114.4 milliliters, which is less than 420. I'm good to go. Okay, so pause this again. You try number 3. Here's your known information, so let's make our prediction. Volume goes down, but temperature stays constant. So this will tell you that pressure is going to go up. We are moving at the same rate if we're the gas molecules, but the room just got smaller, so we're going to hit the walls more often. So you should predict that V2 is going to be greater than 69.0 millimeters of mercury. So let's write our formula and then sub in our values. So then you solve and you get pressure is 1790 millimeters of mercury. You only need 3 sig figs. That's why I rounded that way. And that number definitely is greater than 69, so this value satisfies my prediction. So I'm going to call this my answer. Alright, so for your homework. Alright, so your homework is page 186, numbers 1 through 5. Page 186, numbers 1 through 5. You need to show work, though, for all of those. So if you don't have enough room in your book, you can do them on your computer. Page 186, number 1 through 5. I will tell you, if you look at number 2, number 3, number 4, they just tell you the pressure is millimeters or centimeters. You're going to assume that that's millimeters of mercury or centimeters of mercury. All right, I will see you guys on Monday. And if you need me for tutorials on Monday, just a reminder, I posted it on the website. I will not be available for tutorials on Monday until 8:30. I have a meeting at 8:15.